All right, problem number 2 out of the packet. This is page 5. This one's a little bit more complicated because this time it's actually going to end up as a quadratic equation, but it starts off the same. So in this case, if I read the problem, I have 1 liter flask is filled with 1 mole of H2, 2 moles of I2. You're given the temperature. We're going to calculate the equilibrium for the reaction, right? So we have H2 plus I2 makes HI, actually 2HI. Initial concentration, since it's 1 mole in 1 liter, that's a 1 molar solution. I was 2 moles in 1 liter, so that's a 2 molar. We don't have any HI to start with. Change, this loses, this gains. Coefficient tells us that it gains 2x, right? Again, I don't know any of those equilibrium concentrations. In fact, my goal is to find out what those equilibrium concentrations are. So, I'm going to take 1 minus x. I'm going to take 2 minus x. Initial minus the change, right? Initial minus the change. For the HI, we're just going to end up with 2x, right? Next thing you want to do, we're going to write out my KEQ expression. So, KEQ is equal to HI squared over hydrogen times iodine. So you write out your equilibrium constant expression. Next, we don't know what these values are, but we can use these as placeholders. So I'm going to plug in and substitute. Also, if you read the problem, KEQ for the reaction is 50.5. So I'm going to plug that in as well for KEQ. So 50.5 is equal to, this is 2x squared. Make sure that you put that in parentheses. The square is outside the parentheses. Divided by, for hydrogen, we're going to substitute 1 minus x. For iodine, we're going to substitute 2 minus x. Right? Again, when you're right here, this is really just an algebra problem, right? So we need to put on our algebra skills and start to simplify and solve for x. So I'm going to maybe skip a couple of steps if this would be a good spot for you to push pause, get caught up, make sure that you're right here, and then we're going to start to solve. So if I'm solving, my first thing was get the things out of the denominator. So I'm going to multiply both sides, and I'm going to rearrange. I'm going to get 50.5 and here 2x squared. Watch this. It's not, we got to remember the square goes for the 2 and the x. So it's actually 4x squared, right? Those parentheses are important. Now, here, you know what you got to do. You got to FOIL this, right? So remember in math, and again, if you want to push pause, this is kind of like a Martha Stewart video where I've already solved it. So it's like I'm putting the pie in the oven, and then magically 20 minutes later it comes out. So my next step right here, you're going to go, I got to cheat, I know. So I rearrange, and now I gotta distribute that 50.5. So I'm gonna, again, push pause if you need time to do the math. So I'm distributing that 50.5 to each term. So I got this equation, 101 minus 151.5x plus 50.5x squared minus 4x, or excuse me, equals 4x squared on the other side. Still with me, right? Now I'm going to combine like terms so I can move this 4x squared over, subtracting. I'm running out of room, so I'm going to move it over here, and I'm going to write the final quadratic equation that I came up with, and I'm also rearranging so that I end up with the first term has the highest exponent, and the second term has the next highest exponent, and so on. So when I rearrange it, I get 46.5x squared minus 151.5x plus 101 equals 0. You recognize that as a quadratic equation, and so here you can use your friend, good old quadratic, negative b plus or minus square root of b squared minus 4ac, all divided by 2a. I did this math already. Plug in each term where it belongs in the quadratic. Again, if you need to push pause, get caught up, make sure that you see how to get to this spot. I got x is equal to 0.94 or x is equal to 2.3. Right? I have to be able to plug back into my change line. So if I think about this 0.23 value, if I started with 1 molar H2 and we lose 0.23, we'd end up with less than none of the hydrogen. You can't have less than none. And so this 0.23 value does not make sense, right? This 0.94 value does make sense. And so if I plug it back in, that would make the concentration of the hydrogen 1 minus 0.94, 0.06. For the iodine, 1.06. And for the HI, I would get 1.88. So those are my equilibrium concentrations for each of the substances. Now you know why you learned the quadratic equation, right? Good job. It's been brought to my attention that this is 2.3, not 0.23, 2.3. I apologize if I confused you.